It is a bit outrageous. Yeah, it kind of. Yes, but I'll be honest, not today though.
No, I'm just saying, like, if I took it apart, like, would you be mad at me?
No.
You asked that question last time.
I know, but then I never got it. Then I never got it apart.
Well, but then you never got it apart.
So maybe today's the day.
Okay. But obviously we do have our things to get done though, right? Algebra 2 stuff to get done. So let me take you guys through just vision as to what the next few weeks are going to look like. Just so we are all on the same page with this. In regards to today, I am going to be continuing with some series and sequences practice. And yes, I know you have your beloved intervention period. Just so you know, for today's intervention period is going to be more of a catch-up because you do have a post-assessment due for me today, but it is going to be more of a catch-up in the sense that I'm not going to be assigning anything brand new for the intervention period today. It is the only day this week that I see you. It's a 5-day weekend, so I won't see you again until next Tuesday, Thursday. But I want to take you just on a preview of the next few weeks. Pay close attention to this. You guys are period 3A. I have you Tuesday, Thursday next week. It's a regular week. You just have Monday off. Then the week of the 7th, and in fact, I'm going to turn the laptop so they can see it as well. Here we go. So they can see what I'm pointing to. But then the week of the 7th, now that is a normal week in terms of the time of the day. You're here till 2 o'clock each of those days. You go to all 4 periods each of those days. But then I have you on Monday the 7th and Wednesday the 9th. Now, those 2 days, I plan on reviewing, whatever we need to review. I may actually extend that review a little bit to Thursday, June 3rd, depending on what I need to get done with you, because you will be taking your exam on Friday, June 11th, just so you are all on the same page. So after today, I have 2 days next week, and then I have technically a day and a half after that. And then you have your final exam. So just please make sure you're aware of this timeline. I want to make sure that everyone's on the same page with that. Now, the following week during actual final exams, obviously seniors will be doing their thing. Seniors will be excused, whatever. I will still have to take a regular attendance on Thursday, June 17th. I will still have to take a regular attendance. Seniors will be excused. Now, will we be doing anything on Thursday, June 17th? No, we will not be doing anything that day. You will have taken your exam unless you owe me something. And if you owe me something, then maybe that's an opportunity to make something up. That'd be great. But I will have to take a regular attendance on that day for those of you that are not seniors. And then you all know the debacle that is Friday the 18th, where you go to like all 8 class periods in one day. Once I don't know. Maybe.
Wait, the 18th is the last day of school?
Welcome to the party.
What? Wait. So, the 17th, yeah.
If you don't want to be marked absent, yes.
Oh my God, Brianna, we should go to the beach.
But I'm just being very upfront with all of you. I will be taking a regular attendance that day. If you're virtual, I will be taking a regular attendance that day. Well, if you would have to be specifically a virtual student. So here's the thing. If you are a student who is Monday through Friday live, and you are absent from class, I mark you absent in Genesis. But if you show up in the live stream, you're still absent in Genesis. I just put a little note saying that you were in the live stream. Yes. As long as it says it on Genesis. On Genesis, it gives me a marking for every student. Well, that's not up to me. But I'm just saying that if Genesis says it, then I go with that. So, question? I thought you were handing up for a half a second. Okay, good. All right. For those of you in the live chat, thank you so much for the comments so far. If you haven't left a comment yet, please make sure that you do so. I do see all the wonderful comments that we got there so far, and Joe's overexcitement for being here. That'd be great. Now, in terms of today, like I said, I want to kind of continue delving into sequences and series. I have some practice problems that I want you guys to do. I have a worksheet that I'm going to be handing out to all of you here, a PDF that I'm going to be sending to the students that are virtual at the moment. But with that, if you do not already have them out, I'm going to need those notebooks out and open. So let's see here. I'm going to be posting the PDF that the virtual students will need for today. This one right here. PDF for today. Post. And for those of you that are here live, I'm going to be giving you a copy of this. Let's see. 1, 2, 3, 4. There's 4 in there. So I get the 4 there. 3 in there. And there's 2 in there. So for those of you that are virtual at the moment, please make sure you are checking. Oh, it says there was an error. Please try again. There it goes. So for those of you that are virtual, it just posted now. That'd be great. So we're going to be working with this worksheet over the next couple of class periods. Over the last couple class periods, I've introduced to you the idea of sequences and series. Talked about 2 main sequences and series being arithmetic and geometric. On the front of this worksheet, on the 11.2 side of this worksheet, I have all of my arithmetic problems. That's what we have up on the screen right now. On the back of the worksheet, which for those of you that have the PDF online, it's just the second page. But on the back of this worksheet, you will see a bunch of problems that have to do with geometric. Now, in an attempt to keep this as simple and straightforward as possible, I'm not going to go into some of the more advanced things that you could do with sequences and series. I want to stick with the general surface level stuff so that we have just what we need to finish up this particular year. Of course, I'm kind of gearing you up for like a few problems that will appear on your final exam. So what I'm going to ask for your notes, if I can get this thing going on right here. Today is May 25th. I don't know why I wrote May for some reason. I usually just put the 5/. I know, it really is weird. So I'm going to have you guess a number right now. No, let me ask the question, and then you can guess the number. Okay? I'll give the title of this while I'm saying it. I am 37 years old. My dad had a birthday yesterday. How old is he? I am 37. My dad had a birthday yesterday. How old is he?
At least 37.
Wow. Yeah, take a guess.
53.
How old would he be? Then he had me when he was 15?
Oh, I don't know.
37. Let's say he was. Looks like a recently. When did people have babies?
Exactly, right? When did people have babies?
62.
No,
59.
no,
61.
no,
60.
no.
59.
You guys are way off.
65.
Yesterday, my dad turned 82.
What the?
Wow, what a reaction.
No way.
Yeah, he turned 82.
I don't.
He was 44 when I was born. Yeah. I was born in 1983. 83. My dad was born in 1939. Yeah. Crazy, right?
He's one old son of a gun.
I know, right? Here, hold on. I'll show you a picture. My mom sent this to me the other day when we dropped off my daughter at their house. Well, there it is. There's a picture of them. I'll zoom in. There's a picture of them walking the dog. It'll focus.
What?
Yeah.
Oh, Mr. Marcus!
That's my dad. He's 82.
Yeah.
He doesn't look 82.
Is he single?
Wow. My mom literally sent me this text message, and you're like, is he single? What a world we live in.
Yeah.
What embarrassment might be coursing through your veins right now.
Wait, so your mom's the same age?
No, she's 73.
Oh, ow. So, wait. What?
9.
Yeah.
Anyway, back to this.
She's 9? That's a little weird.
Wow, I said 73. Anyway, I'm on the 11.2 side of this worksheet. And the first thing that I want to do to kind of recap what's going on is to write down problem number 5. Now, obviously, you have this worksheet. You can see exactly what these numbers are, and you can see exactly what the directions are for those problems. But I want to do number 5 together, and I want to answer everything that there has to do with number 5. And then I want to set you guys off on a few problems of your own. I want you to be able to try some of these problems and be able to piece together the puzzle that they are posing to you. For number 5, they give you a sequence. Now, in the directions, they tell you that it is arithmetic. Now, besides the directions literally saying it's arithmetic sequence, how do you know that this sequence actually is an arithmetic sequence? What tells you that it's an arithmetic sequence? Mr. Markey, it has a pattern, but that doesn't mean anything. All sequences have patterns, all of them. That's the definition as to what a sequence is. But there is something specific that makes this an arithmetic sequence. What property might that be? I put arithmetic and I said because ... What kind of pattern would you describe for this sequence? If you had to verbally describe a pattern, what would that pattern be? Yeah, well, what would you describe the pattern as? Like if I said, how do I get the next number? What would you tell me? Subtract 7. Yeah. Now, here's the reason why it's arithmetic. Because according to the definition, there is a common difference of -7. An arithmetic sequence, you are adding or subtracting the same number every time. That is why it is arithmetic. That is the pure definition as to why it's arithmetic. Now, after we get the general rule for this problem, which we have not gotten yet, but after we get the general rule for this problem, I'm going to, again, expand upon this just a little bit to make you think back to what you've been taught in middle school. But we'll get there. We'll get there. Now, for this problem, they want me to write a rule, a general rule. So I'm going to write this down one more time. The formula for the general rule of an arithmetic sequence. We wrote this down last week. We wrote it down multiple times. My purpose right now is to just remind you and to jog your memory as to what the heck we did last week. Using this formula, I can get the general rule. I just have to do a couple things. Number one, I have to plug in the first term, which is clear as day. I can see the first term. It's a 5. And I have to plug in the common difference, which we visually identified as a -7. I got to clean this thing up a bit. I'm going to clean this thing up a bit because I do have to simplify this thing out. I'm going to distribute that -7 right here. Please be very careful when you are distributing that negative, because negative times a negative should give you that positive. And ultimately, I get this as my general rule. This formula at the bottom is important. it governs that entire sequence. It tells that sequence what to do. It tells that sequence where to start. It can tell you any term in that sequence. It can tell you the, well, 1, 2, 3, 4, 5. We have 5 terms up there. It can tell you the 6th term. Now, clearly, we kind of know what the 6th term's going to be. Like Ms. Reggie, look, it's just -7, -7, -7. So the next one should be -30. Yeah, it is -30. But if you were to plug in a 6 into that formula at the bottom, -7 times 6 is -42. -42 plus 12 will give you that -30 as well. And Ms. Reggie, I could just easily count it. I know. But what about like the 50th term? What about the 170th term? What about the 50,000th term? You don't want to count up -7 the entire way. So instead, we just have that formula. What does this formula look like to you? What does this formula resemble from what you learned back in Algebra 1 and pre-algebra? What did you guys even do in pre-algebra? Do you even remember?
What grade was pre-algebra?
Middle school, dependent who the person was. But it definitely was middle school. 6th, 7th, 8th grade?
All I remember is playing a game.
Which game? Was it Green Globs? Oh, okay. I like Green Globs. Green Globs, they had like an XY plane, and then you had to write an equation that would hit as many of the Green Globs as possible, and then you get a score. I would cheat all the time because I would use like 6th and 7th degree polynomials to be able to hit them all in one shot. That's not what we were supposed to do, but I cheated the system. But here's the thing. What you did in pre-algebra, what you did in Algebra 1, you did a ton of linear equations, did you not? Didn't you learn what they looked like? Didn't you learn how to graph them? Learn how to identify the slope? Learn how to calculate slope? Learn how to find a y-intercept? Hold on, let me rephrase. Hold on. Let me put this in quotes, and I'll do this for the people online too. Hey, in middle school, didn't you learn, I'll put this in quotes, learn linear equations? Yeah, I put that in quotes because a lot of people are just like, I barely remember anything about linear equations. I know you do. But what I need you to recognize is this. Arithmetic sequences, I need you to think of them. I misspelled it. I'll squeeze that A in there. I need you to think of them as linear. I'm a math teacher. I don't know how to spell. You need to think of them as linear. This equation that you found at the bottom, this general rule, is in mx plus b form. It is a linear equation. That is going to be helpful for some of the problems that I have for you. Now, just for the sake of argument, the rest of the problem, they did want you to find the 20th term. You could find the 20th term by just simply plugging in a 20. Put that over here. By plugging in a 20 into that formula, -7 times 20 plus 12, you don't have to actually count up that high. It spits out a -128. That's how great the formula is. That's how wonderful that formula can be if you use it properly. Here's what I want you to do. I have a couple problems that I want you to try. I have a couple problems that I want you to see if you can get to the ultimate goal of the answer. Now, what I'm going to do is I'm going to tell you what these problems are, number one. And then number two, I'm going to help you kind of set them up a little. The three problems that I want you working on are number 7, number 12, and number 15 on that worksheet. Now, I will tell you that I would prefer that you at least get done numbers 7 and 15. Those are my goals right now. If you can get done 7 and 15, then you are in good shape. If you want a challenge, if you want a bit more of a challenge, if you want to see if you can handle a more difficult problem, then I would suggest number 15. At the very least, you can get done 7 and 12. Now, like I said, I want to help you get a little bit started. I'm not going to do the whole thing for you. But for number 7, it's just like number 5. It's literally just like number 5. It's just a different sequence. There's no craziness going on there. It's just a different sequence, but they want you to get a similar answer to what you got in number 5, just with different numbers. Number 12, for number 12, they don't give you the sequence. In number 12, they give you the common difference. Now, the thing is, in order to use that formula, you need the common difference and you need the first term. Well, they don't give you the first term, they give you the 12th term. You have to figure out how to get the first term. 7 and 12 are what I would prefer that you focus your energy and attention on. But if you are so inclined to give it a shot, you could also try number 15. Now, I will tell you that number 15 is a little more of a challenge. Number 15 is a little more of a challenge. So if you really want to push yourself and see, do I actually know how to do these problems? Can I actually handle what's going on here? Then try number 15. Otherwise, don't worry about it. Focus on 7 and 12. I'm going to give you guys the next 5 or so minutes, maybe 6, depends on how I feel, to get at the very least the top 2 problems done. And if you can get done 15 as well, go for it. Let's see what we get. Okay. Let's see where we got with any of these. Again, I'm just going to go through them one at a time. Again, I just wanted you to at least get done number 7 and 12 to be able to try your hand at those. Number 15 is a bit more challenging because I haven't fully explained how to do something like number 15. But let's see how 7 and 12 hold up. For number 7, you could clearly identify what your first term is just by looking at the problem. And hopefully, it was very straightforward to identify that your common difference was a positive 7. Finding that general rule means just plugging in those two numbers into that formula that we've been using over and over and over again. You still have to simplify this thing down after plugging them into their proper locations, and simplifying them down would look something like this. Ultimately getting your general rule of 7n minus 5. That is what the general rule should be for number 7. That is what the formula should look like. That is the form that it should take. Okay. Now, it does say to find the 20th term. For the sake of argument, I didn't really think about that per se, but if you want to find that 20th term, we're looking over here. 7 times 20 minus 5. Clearly, a lot of people could do that kind of calculation directly in their head, but the 20th term should be 135. That was kind of a side note. The general rule is what I'm really focused on and what I'm really interested in getting. For number 12, the problem is that we don't have the first term. We don't know what the first term is. If you are so inclined, you could count backwards from the 12th term. The common difference is 2. So counting backwards from the 12th term, 11, 10, all the way down to 1, you could just go backwards, -2, -2, -2, all the way down, if you wanted to. But you don't have to. There is a strategy that I showed you last week for getting that first term, and it is a matter of using the formula once again. Notice right here, I'm trying to use the formula where I'm plugging in all of the proper information. I'm plugging in the 2 for the common difference. And instead of a sub n, notice what I plugged in here. I did a sub 12. Well, a sub 12 in the parentheses ends up being 12 minus 1. We can calculate that. We can figure out what that particular part of the problem would end up being. This strategy is incredibly helpful when you have to find the first term. I know that a sub 12 is equal to 18 because, well, they told me. They literally told me a sub 12 is equal to 18. And because of that, I can get the following calculation. 12 minus 1 is 11 times 2 is 22. From here, a sub 1 equals -4. Now, I'm not done yet. That's not my final answer. All I've been able to find out so far is, well, that is my first term. That's my first term. Knowing that it is my first term, I can now go back finally to that other formula, or the original formula, I should say, and plug in the appropriate information, just like we did on number 7, just like we did on number 5. And we end up with something that looks like this. Once you simplify it down, that is. That is what the general rule should have been. That is what the general rule looks like. Once again, an mx plus b form equation, yes. But you had to take that extra little step right here of finding out what that first term was. It's a good strategy. Now, I told you 15 was a little bit more of a challenge. And yes, if you wanted to handle that challenge on your own, by all means, you could have done that. But let's go over what number 15 entails. They don't give me anything. They don't give me a common difference. They don't give me a first term. I need you to think back. When I say think back, I need you to think back to pre-algebra. I need you to think back to algebra 1. I need you to get past all of the negative feelings that you had towards mathematics all those years and dig deep and think about what in the heck am I doing right here? What the heck is that? What is that? What am I doing there? What am I actually calculating there? I have not shown you this year. Or maybe I have shown you this year, but I did not originally teach you this. If I did show you this year, it's probably in passing, because it comes with the assumption that if you enter the room of Algebra 2, that you have learned this in the past. What the heck am I calculating here? What equation or formula am I using here? My goodness. I'm somehow subtracting these two numbers on top. I'm subtracting these two numbers on bottom. Your Algebra 1 teachers would turn in their graves if they were dead. Although some of you would hope they are dead. You're calculating slope. You're technically calculating slope. Arithmetic sequences are linear. Arithmetic sequences are linear. And because they are linear, your common difference is actually your slope. That's what this thing actually does. It's really messed up. But you can calculate that slope, and you can get negative 12 over 4 or a negative 3. You have just found your common difference. You have found your slope. Mx plus b, well, that m is now your d, the common difference. Ultimately, you do have to find that first term once again. You do have to find that first term once again, which I'm going to write this out using a sub 7. A sub 7 now equals my first term plus parentheses n minus 1 times negative 3. And the whole process starts all over again. It's pretty much the same process over and over and over again. A sub 7 equals negative 22. Negative 22 equals my first term plus, well, this should be really a 7 right here to get negative 18. A sub 1 equals negative 4. It's just another piece to the puzzle. The fact that you are now taking multiple steps each and every time to get a little bit closer to what that general rule actually is. It's kind of nice. Minus 3n plus 3. You end up with the general rule of this. Now again, this was a challenge problem. This number 15. It was a challenge problem. If you did number 15 or attempted number 15, then good for you, absolutely. But I was not, I told you at the very beginning, I wasn't requiring number 15 to be done. I just wanted to see, well, if you really wanted a challenge, take a look at it, see what you can do. I don't tend to put challenge problems per se on my assessments. We'll see how that goes. Yeah. Oh, cool. Good job. How many Greek letters can you name? Name them. Omega is a Greek letter. Delta is a Greek letter. Keep going. That's two. There's a lot more. There's well over 20.
No, I'm just kidding.
I'm just trying to think about like in movies and like frat houses, fraternities and stuff.
That's where most people think of Greek letters. Come on, you guys are forgetting your most famous Greek letter of all time. No? I mean, beta is a Greek letter. Pi. You know, pi was a Greek letter?
Really?
Yeah, it's a lowercase Greek letter.
That's cool, but in this classroom we hate pi.
That's true. That's why I hate it.
Like we hate pi in this classroom, so that's why I blocked it out of my brain. I don't even like to talk about it.
On your worksheet, look down at numbers 23, 24, and 25. What do you see there? Looks like a backwards E? Oh, it looks like a forward-facing E.
That looks like a sideways M.
Could be a sideways M. You'd all be wrong, by the way.
Oh, it's a that's a delta.
Nope.
I don't have it.
Nope. Greek letters in mathematics have all sorts of meanings. In statistics, we use alpha, beta a lot. In statistics, specifically for hypothesis testing, obviously you guys use pi in geometry a lot more than anything else. I know, right? Seriously. You guys, delta, technically that slope formula, you ever talk about the slope formula as like change of y over change of x? And when you do that, sometimes you do a little triangle. Have you ever seen that? Here, I'll show you what I mean. That's actually what delta is. When you do y2 minus y1 over x2 minus x1, that's actually change of y over change of x. That's delta. It's interesting how much people don't recognize Greek letters in the mathematics realm. They recognize that more what you were saying before about like sororities and fraternities, you know, in terms of calculating things. Obviously, in linear algebra, a college level course, we do stuff with like something called lambda, which is another Greek letter. Huh? Wow, I don't like where this conversation went.
Well, were you in one?
No.
Yeah, I can't imagine you. You were if you were in one, you'd be like in like a math one.
I'd be in a math one.
Yeah, is that a thing?
No.
I don't want to be in a fraternity.
There is fraternities.
Why do you keep doing that? I don't want to be in
I'm bringing up all this stuff about Greek letters because I have to explain what that symbol is on the page. By the way, you know, every year they name hurricanes, right?
Yeah.
And there's actually a pre-established list of names that they approve like 5-10 years ahead of time. So when a hurricane forms or a tropical depression or tropical storm forms, they name it. They go down that list starting with A, going all the way down. But every year the names change. And if a storm made a significant impact, like Sandy or Katrina, they retire the name and it's never used again. I don't know if you knew that.
I did, but now I do.
Here's something you probably didn't always know. There are 26 letters, but they don't have 26 names. They have about 23 or 24 names. Every year they have an appointed list of hurricane names. Hold on. The 2021 Atlantic Hurricane Wiki. Boom. Here are the list of names for this particular year. So far, they've only named Hurricane Anna. But the list of names, where'd it go? Timeline. Here we go, storm names. Anna, Bill, Claudette, Danny. These are going to be the names this year, just so you know. But yeah, check this statement out. If there are more than 21 named storms this season, subsequent storms will take their names from an auxiliary list of names approved by the WMO. Previously, the Greek alphabet was used. So they would do Hurricane Alpha, Hurricane Beta, Hurricane Gamma, all the way down. They happened in 2005, I want to say, during the year of Hurricane Katrina. Now, you guys probably don't, you don't remember it firsthand, but did you learn about Hurricane Katrina?
Yeah.
And the impact that it had on the Gulf Coast and New Orleans and stuff like that? Yeah. But yeah, that practice was actually, you could see, discontinued as the 2020 season brought multiple shortcomings to light, using the Greek letters, blah, 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 blah. So just interesting, I thought. Well, what I need to show you is this symbol right here. And I need you to write this symbol down, copy it down as best you can. So I'm going to show you what it is and how to use it. This is the Greek letter sigma. This is the Greek letter sigma.
Sigma?
Yes. And it means the sum of. It means the sum of. Now, with these arithmetic sequences, a lot of this comes down to, well, the sum of a certain number of numbers. And we are going to do that. We're actually going to do number 23 using this information. So what you need to know about number 23, when you see this and it says that Greek letter sigma, it's asking for the sum of well, not necessarily an arithmetic, but for the sum of a series. Now, in this case, you know that the series is arithmetic based on the equation that they give you. The equation that they give you right here, the one that I'm pointing to, this is linear. It's linear, thus it is arithmetic. And if it is arithmetic, then you would try to use this formula that we wrote down last week. Now, what the heck do we need for this? Well, we need the number of terms being added up. We need the first term. We need the last term. That's all that we need, actually. We need the number of terms being added. We need the first and the last term. That's what we need. Well, let me explain to you what this sigma is actually doing to this equation, what all these numbers are. Look very closely at what I'm pointing to when I say it out loud. This problem says, find the sum of, that's the sigma, find the sum of this arithmetic sequence starting with I equal to 1 and ending with I equal to 25. I'm going to do that again, but look very closely at how all these symbols work together. I know, right? Sigma, it says, find the sum of this arithmetic sequence starting with I equal to 1 and finishing with I equal to 25. Start with the first term, end with the 25th term. How many terms are they asking us to add up? This is not necessarily a straightforward question, but if you're starting with term number 1 and you're finishing with term number 25, how many terms is that? Cricket, cricket. You could guess and possibly stumble on that answer.
Okay, see, so would that be 23, 24, 25?
It would be 25. Why would it be? I can see why you might guess 24, but why would you guess 23?
Because like 25, but you already have 25 and you already have 1, so 23.
Ah, okay.
Do you see where that
I do see the logic. I do. But keep in mind that you don't have any of the terms right now. We haven't found any of them.
Oh,
But they want you to add up terms 1, 2, 3, 4, 5, 6, all the way up to 25. Yeah. There are 25 terms to add up. Parentheses. I need to figure out what goes on the top of this fraction. Well, if I want to find a sub 1, I'm going to plug a 1 into that equation. If I plug a 1 into that equation, I get negative 5 back. If I plug a 1 into that equation, I get negative 5 back because 2 minus 7 times 1. I need to plug a 25 into that equation. I'm going to have to go to my calculator for that one. 2 minus 7 times 25, that spits out a negative 173. Ugh, that's gross looking, but that's okay. The calculator's going to get a lot of this done for us. The first term is negative 5, and the last term is negative 173. If you can identify those three things, the number of terms, the first term, the last term, then you can shove them into that formula and get that correct answer. Oh, sigma. I know, right? Do you know what's a more important number than pi? Mind you, sigma's not a number. Sigma's not a number, but do you know what's a more important number than pi? Is the number phi, P-H-I. That actually is also a Greek letter.
We like five.
I'll show you what phi is. Would it surprise you to know that I have an entire book based on phi? Shouldn't be surprised. Phi is, like I said, quite possibly one of the more important Greek letters and numbers in history. Here's the capital Greek letter phi right there. It'll focus in a moment. There it is. Yeah. Capital, lowercase. We use Greek letters all the time in mathematics, just that you don't necessarily realize it. So then if I do this calculation, let's see, -5 plus -173 divided by 2 times 25, I get this messed up answer. -2,225. It's just a matter of taking it a step at a time. Okay. There we go. That's there, and here we go. Next week, we are going to wrap up this stuff with some geometric. I've already introduced to you the geometric formulas, but next week we are going to getting the practice with the geometric formulas. On Thursday of next week, my main objective would most likely be to wrap this whole thing up and to have some kind of an assessment for you on sequences and series, which I think I already have the beginnings of in the back of my mind, but I will let you know more about that next week. We're about to enter the intervention session or whatever have you call it of this particular class period. I am not assigning anything brand new, but there are a number of things that you all potentially owe me. He's over right there. Thank you.
I'm sorry.
You're fine.
I tried.
Okay. There are a number of things that you potentially owe me. For example, there is a post-assessment due tomorrow that I can see that a few people have already gotten done. I'm looking at the Google Classroom thing right now. There is a previous post-assessment that some people still owe me, remediation enrichment, and a major assessment that was due at the end of last week. Right now, you guys have roughly a half an hour. I would like you to take advantage of this intervention period. I'm not assigning anything brand new, but there are a number of things that you potentially owe me for the fourth marking period. So I'm going to strongly suggest that for the next half hour during this intervention period, that you take advantage of this time, use it effectively, and get done what you need to get done. Check Google Classroom, see what you haven't submitted to me yet, and let's jump on this stuff. Of course, for the live stream, I'm going to keep this open. I'm going to keep it open. I'm going to have the live stream open at my desk. So if you do have any questions, I can answer them in real time. And of course, if there are any specific questions towards like grades or what you particularly owe me, you could, of course, email me. Yep. You could have emailed me about that. Gosh. Anyway. But yeah, let's jump on that information. Let's go. That's not us.
Yeah, time to go to bed. Oh, yeah, yeah, yeah.
Bell's going to ring in about a minute. Like I said, I am going to be checking what things have been submitted over the course of today and tomorrow. But then we do have that 5-day weekend, and I will not see you again until Tuesday. So please make sure that you are jumping on top of those things that you owe me, because we are very quickly getting to a point where we're going to be reviewing for our final exam, and that marking period will be coming to a close. If you have not left a comment in the chat, please make sure that you do so. I've already gotten the ones that have been left so far. Bell's going to ring in approximately 20 seconds or less. I know what I'm going to be working on tomorrow. Look at this thing. It's already falling completely apart. Wait, did you just try to... yeah, you tried to shove a piece in where it's not supposed to go. Yeah, that's okay. We'll figure that out. Anyway, everyone have a good one, because there's the bell. Yeah, the pieces are not... because you got it right